Sophie. I used to work at Facebook and manage the React team, but then I abandoned them in January. Now I'm an eng manager at a tech startup called Humu, where we're trying to help people build work environments that are more fulfilling and empowering and inclusive. And you can find me as Sophie Bits just about anywhere on the internet. So today I want to go under the hood of React a little bit. Since you're here, I assume most of you use React, but I'm guessing you won't know most of the things I'm going to talk about in this talk, and hopefully you'll learn something. You probably read the title of the talk on the schedule, so you know where this is going, building a custom React renderer. But I want to start with some of the basics. So when you sit down and write down some of the different parts of React, you might end up with a list something like this. Let's see, you have the built-in components. Those are like div and span and image, things like that. You have function components. You have class components. You have props and state, and effects, and life cycles, key, and ref, and context. You might know react.lazy, and error boundaries, and then the new stuff, which is concurrent mode and suspense. And you've probably also heard of React Native. And in React Native, everything on this list behaves exactly the same, except for this first line, these built-in components. Instead, on React Native, you have components like view and text and image, things like that. And they take a different set of props and event handlers. And so the way React is implemented, the code for everything in this bottom list is completely shared. And on the React team, we call the code that implements this the reconciler. And it's set up to plug into these different platforms, like React DOM and React Native, which are officially maintained by the React and React Native teams at Facebook. And some people in the community have also connected React to other platforms, like 2D drawing libraries and 3D graphics libraries, and even rendering for command line applications that run in a terminal. And so we call each of these platforms a host environment. That's because it's conceptually hosting your copy of React and providing the base level primitives that React runs on top of. And I wrote built-in components here, but usually on the React team we say built-in components colloquially, but our formal name for these is host components because they come from the host environment. And so this reconciler, this bottom list, is part of the code of React DOM and React Native. It's part of what you're getting when you install each one of them. But it's also available as its own package on NPM called react-reconciler. It's not nearly as stable as the main APIs, and it doesn't have a ton of documentation. But you can build your own renderer using that package, and that's what I'm going to show you how to do today. The reconciler package has two different modes, depending on what kind of host environment you're trying to integrate with. The first one is called mutation mode. You use it whenever you're integrating with an environment where you have views that are mutable in some way. This one will probably be a little more intuitive to most of you. And so usually what this looks like is the host environment, you have some sort of create view call. Maybe this returns a view. And then when you want to change the appearance, you mutate this view somehow. So maybe you call it like update view, which takes some new props. So maybe you're setting the color to red. And that will mutate this view in place. And I'm using sort of a generic API here. If you're thinking about an actual DOM API, this would look more like document.create create element. This will return a div. And then to update the color, you might do div.style.color equals red, something like that. And so React DOM is built using this mutation mode because mutation is how the DOM itself works. The other mode is called persistent mode. And I'm not going to talk too much about this today, but I do want to just mention it. It's used for if your target is an environment where the API treats the tree of views as persistent, immutable objects, where instead of mutating a view in place, you create a new version of it each time you want to update it. And so that looks something more like create view And then instead of update view and changing it in place, maybe a call like clone view, where, again, you pass it some new props, but instead of changing this view, this returns a new view, like a new version of that same view, and then you need to update the parents to point to that new copy. The next generation version of React Native that the team's been working on for a while uses this mode because it's more efficient in several cases, especially with concurrent mode. And in React Native, we have complete control over the environment, so we can make it work like this. So the one that I'm really going to dig into today, though, is mutation mode. Whenever React does a render or a re-render, including for a state update, it calls into all of the relevant components in the application. It does a sort of diff, and then it comes up with basically a list of commands for what needs to happen in the host environment. Commands like update view x to be red, or it might say create a new view, or it might say add that view you just created as a child of view y, something like that. And so our job in bridging React to this host environment is to implement how each of these commands works. I suspect that many of you are familiar with the basic DOM APIs like document.createElement and div.style.color. So to make this a little bit easier to follow, what I'm going to build today is a simple version of React DOM. This might not be quite as exciting as building against a flashy new platform, but you can take what I'm going to show you here and apply it to any platform, not just the DOM. So let's get started. My base here is going to be a create React app, which most of you may be familiar with. And if I open index.js, you can see that it's using the real version of React DOM. It's importing from that React DOM package. And what I'm going to do is just take out React DOM and replace it with our own version. So I'm going to make a new file. I'm going to call it React DOM mini. And then I'm going to import that file. And then instead of React DOM.render, I'm going to call React DOM mini.render. And it crashes because I haven't actually implemented anything in this file yet. But in my render implementation here, this React DOM mini.js, I want to start by importing the reconciler module from NPM. So this is import react-reconciler from the react-reconciler package, which I installed in my project. That's really the only change I made from a plain new installation of Create React App. And so this is the package I mentioned that has all of the guts of React that are shared across different platforms. And so the basic structure here is I'm going to instantiate React reconciler. And this takes a sort of config object, which is configuration for how to talk to the host environment. Or we sometimes call this the host config. And this returns a reconciler. And then the API for this reconciler object is slightly different than the top-level API of React DOM. So in order to make the .render method available that we're calling here in the index file, I need to define, I need to define an object, which I'll just give one method. And render should take two arguments. The first one is what we're rendering, and the second one is the container we're putting in. So this is what to render, and then the div we're going to put it in. I'm going to export this. When the render method is called, we're going to want to call into the reconciler somehow so that this thing we want to render actually gets passed to React. And so if I reload now, I'll see a white screen because my render method doesn't do anything yet. And in this host config, there are actually a whole bunch of methods that you need to implement to get a working render. And so I'm gonna paste in a little shell here with just some stubs for methods. You can see that I'm starting with supports mutation : true. That means I'm going to use that mutation mode I talked about. And then I have a bunch of methods here where all the implementations are empty, but that'll just save me a little time typing later. And don't worry too much about reading all the names. I'll tell you about the important ones as we fill them in. I'm also going to fill in this render method with a couple lines where the reconciler has its own notion of a container. So I'm going to first do reconciler.createContainer, pass it this div a couple false arguments, which I believe are for concurrent mode and server-side hydration, neither of which we're using today. So this returns a container, and then I call reconciler.updateContainer with what to render and a reference to that container, and then a couple of nulls. And I don't need to return anything. That's all I need to do. So the first method in this host config that I'm going to implement is called createInstance. This gets called whenever there's a new host component that we want to put on the screen. It has a bunch of different arguments, but the ones we really care about are type and props right here. So I'm going to start by just logging type and props. And if you look at the DevTools here on the right side, you can see that type is just going to be a string that is the HTML tag of the element, and then props is going to be a props object for what is being passed to that element. And I want you to notice that already all we have to worry about dealing with is these low-level host components. Even though there is this app component that we're rendering, you don't actually see the app component in these logs here because React is taking care of it before this method even gets called. And so what do we want to do? Well, to create a new node in the DOM, we call document.createElement. I'm going to pass it the type, which is, again, the tag name that we're using. I store that in a variable called el. And then I want to deal with the props as well. I'm going to start with just class name. So if props.className is present, I'm going to do l.className equals props.className. And if props.source, I'm also going to do source because there's an image and it won't look right if we don't have the source. I'm going to do that the same way. And then we're going to return a reference to this element. It's worth noting that React itself is not designed to be tied to the DOM, so it doesn't actually have any idea what a DOM element is or how to interact with it. So you might be wondering why we even need to return it here from createInstance. The answer is that react-reconciler isn't going to call any methods or set any properties on this object, but what it is going to do is pass it back to us in some of these other methods so that we can manipulate it later. So React doesn't actually care at all what the shape of this return value is. So if I wanted to return maybe some other data with it, I could return an object that has some other data here. And React doesn't care. But for our purposes, it will work for me to just return the element. I also didn't tell you yet about a second type of host component that we also need to implement, and that's a text component, or more specifically, a host text component. When you write some code like this, where you say div, and maybe it says click here, and you have a button. You can see two components already. You have the div component and the button component, but there's actually a third component here, which is for the click here text. So whenever you have a string or a number in your component hierarchy, React is going to create one of these text instances. And the implementation here is pretty simple. We get to just call document.createTextNode and return that. The browser here is going to return to us a DOM text node, which, if you're not familiar with them, is pretty similar to a DOM element. It's just a different type of DOM node that can live in a DOM tree. And when the browser renders it, you can see some text. This is also how any type of text in a page works. Like when your browser is just parsing some HTML, if it sees a piece of text, it creates one of these DOM text nodes. So we're just doing the same thing. So now we're creating all of these instances, but we don't see any of them yet. And the reason for that is that we're not attaching the node anywhere. You need to add an element to some parent in order for it to actually show up in the DOM. And in fact, React should already be calling these next three methods for append child. We're just not doing anything in them. There are these three different methods: append child to container, append child, append initial child, and they're called in slightly different situations. The differences aren't that interesting right now, so we actually want to do the same thing in every single one of them. This child value here is going to be one of the instances that was returned from either create instance or create text instance. So it's going to be either a DOM element or a DOM node. And container here is also going to be a DOM element. And so I can call the DOM's append child API that's built into browsers. So I'm going to call container.append child. I'm going to do the same thing here. So now, each time React wants to add a new element to the hierarchy, it'll call one of these three methods, which will end up calling the DOM's append child API. And so if I save, hopefully, you can see it works. And so you can see we've only written about like 10 lines of actual code, but already we have something on the screen. That's pretty cool, right? I also, before we get into updates, I want to fill in a couple more props here. I did class name and source, but there's actually 6 different props that are used here, and that's why like this learn React thing that is supposed to be a link is not underlined, and I can't click it. And so let me fill those in. Those are alt, class name, href, rel, source, and target are the ones that are used in this app. And so for each of those, I'm going to say if props has that key, then just copy it to the element. And I don't need that anymore. And you can see now I have a Learn React link, which opens the React website. Cool. So we don't handle any state updates yet, which I guess kind of defeats the purpose of using React. So the spinning logo, by the way, is done completely in CSS. There's no JS updates, so that's why that works. But let's change that and add some state. So here's our app component. And for this demo, I'm going to make it so that you can, when we click here, it'll toggle whether the logo is visible. So I'm going to add a state variable, let show logo, and set show logo. React.useState, and that's going to default to true. And then if show logo is set, I'm going to show the logo. Otherwise, I won't. And then I want an on-click handler. So on-click, I want to call set show logo. And I'm going to set that to whatever the opposite of what it was before is. And I made a typo. No, I'm missing a brace here. Here I'm using the functional update form of setState. So I got the old value here, and then I'm supposed to return the new value. And if I reload and try to click, nothing happens. And the reason for that is we didn't ever say what onClick means. The only props we're handling are these ones that we wrote down in create instance. Remember, React doesn't know anything about any DOM-specific properties. It doesn't know what a click is. And so if we want onClick to do something, we need to handle that ourselves. So if I log the props.onClick property, then you'll see on the right side that it is that function that we just set up. And so the logic to actually call this when I click is pretty short. I'm going to say if props.onClick is present, then I'm going to call add event listener on the element, give it a click event, and pass props.onClick as the function. And so if I did that right, now when I click on the page, it's going to call my function, which is supposed to hide the logo. Do you think it'll work? So if I click, then I get an error. And I think the event listener part actually did. We can verify this by adding an alert here. I'm just going to say alert hi. And if I click, I do get that alert. So the event listener is working. It's actually the re-rendering that's throwing an error. And so the reason it's crashing now is that I didn't actually implement the methods that are used for removing things from the DOM, which is these remove child methods. And the implementation here is also going to just be one line. I can call the built-in browser remove child method on the container element or on the parent element. While I'm at it, I'm also going to fill in these implementations for insert before, which is used when we're adding an element in the middle of a list instead of at the end of it. And luckily, we can just also use the built-in DOM API insert before, because it has basically the same API. So child is the same, and then before is another node that you want to insert it right next to. And so I can do this by call. And so now, when I click, does the logo actually disappear? It does. And when I click again, it comes back. So you can see that in our renderer, we didn't have to write any logic specific to state updates or how they're handled or knowing when to re-render, but we were able to use state within our component. Again, that's because React State works exactly the same on every platform, and so it's implemented inside this shared react-reconciler module. And now we can handle components being added and removed. The final big piece I'm missing is updating properties of components that are already on the screen. Let me make it so this text here on the right side has a background color that just changes over time. So I'm going to have a color variable. I'll start with red, and I'm going to add an effect. In this effect, I'm going to have a list of colors. I'm going to cycle between red and green and blue. I'm going to have a counter, and I'm going to call setInterval. So every 1 second, I will increment I and call setColor with the next item in the list. So that's called imod3. We'll loop around. This will return an interval. And then to clean up, I'm going to return clear interval. And let me set this as the background color of this paragraph tag here. Now, up to this point, I've been matching the APIs that React DOM itself uses, and so this component works exactly the same if you were to run it under React DOM. But I want to remind you that we're actually building our own environment here, and so we can kind of do whatever we want. Let's say I don't like the CSS inline style API, and I want to go back to the days of HTML3 where we could just put like a BG color attribute on any element. And so I'm going to do that. I'm going to write BG color equals color here. And then to make this work, I'm going to have to handle it in create instance. Again, I'm going to say if props.bg color. And here I do need to use the style API that browsers have. And I'm just going to set it to props.bg color. And that works. So if you tried to use this prop in React DOM, it wouldn't work, but we make the rules here, so the red background color does work. The effect I wrote is probably working, but the color isn't changing, and let's make that happen now. When React does any state update, it calls all of the components and tries to figure out what changed between the old and new trees. And it does all of this before actually modifying any of the actual host components. These render calls and the diffing happen in what we call the render phase. And then once we've prepared the whole tree, that's when we go to the commit phase, which is when we actually change things in the host environment and mutate the DOM. So to make updates work, we have to implement 2 more methods, prepare update and commit update here. And they're divided according to these 2 phases. Prepare update is called in the render phase, commit update in the commit phase. And so it gets a whole bunch of arguments here, including the old and new props. And it's supposed to return what we call an update payload, which is basically just a diff between the old and new props. So I'm going to make a payload variable. And I'm feeling a little lazy, so I'm only going to compare the BG color props. So I'm just going to say if old props dot BG color is not equal to new props dot BG color, then I'm going to set the payload. And this can really be whatever we want. React, again, doesn't really care what this is. It's just going to get passed to our next function. So I'm going to say new BG color is going to be new props.bg color. I'm going to return that payload. And then in commit update, we get the component instance, which again is the DOM element itself, and the update payload that we just returned from prepare update. So here, what we need to do is we need to say if update payload has a new BG color property, then I'm going to set style.background color equals update payload.new BG color. And I think that should do it. So you'll notice that just like for state, we didn't have to do anything special for the effect to work. React takes care of all of that. It just calls us when it's like, oh, now it's time to change this host component and what it looks like. And so now we have a renderer that can render this page, do some basic event handlers, and handle changes in the component tree, both adding and removing components, as well as updating components that are already on screen. And I think that covers the main things that we expect React to do. And this file is still only about 100 lines. And that's all you need in order to write a basic interface with a new host environment. So I feel pretty good about this. The real React DOM implementation implements these exact same methods. This is how the real one works. It probably wouldn't surprise you, though, to hear that the real React DOM is quite a bit more than 100 lines. And at this point, you might be wondering what the real one does that I didn't build here. And I don't have an exhaustive list, but I wrote down a few of the major differences. In this toy version, we're only handling a few properties on initial render and for updates. We don't have any special support for form controls. There's actually quite a bit of logic you need to handle controlled and uncontrolled components. We didn't build anything in for refs. And so although you can, so if you try to take a ref to one of these host components, instead of getting the DOM node back like you do in React DOM, you just don't have access to it, and there's no way to actually get the associated DOM node in this renderer we built. There's a lot of attribute and event normalization for cross-browser compatibility that I left out, and we don't support SVG. Event bubbling through portals is another one. I didn't actually test portals at all, so I have no idea if they work. And probably a lot of other edge cases I forgot, but I think these are the biggest differences. And that's all I have for you today. I don't know if this talk was super practical for most of you. I imagine it's rare you'll find the occasion to build your own React renderer from scratch. But I hope you found this fun, and I hope you learned a little more about how React works and more than you knew before. Thank you.